Hello, we're going to do some polyatomic crisscrossing today. And the number one thing you have to remember is that polys need parentheses. So anytime you have a polyatomic ion, poly means many, atomic, atoms. So anytime you have anything with many atoms, you need to have parentheses. So if I started out with magnesium, magnesium's not a polyatomic ion, it's right off the periodic table. And it's on group 2. So since it's on group 2, it has 2 valence electrons. And I know that it wants to get rid of those 2 valence electrons. So its charge is +2. And I'm going to cross that with phosphate, PO4 -3. Polyatomic. There's 1 phosphorus and 4 oxygens in phosphate. And I can't look on the periodic table for that. I just have to look on my poly sheet so that I know what charge it is, and that's where I get the -3. So for any of the polyatomics, use your poly sheet. Now when I cross those two, I have magnesium +2, it's phosphate -3, and when I cross them, the 2 goes outside the parentheses, and the -3, again, outside the parentheses, but it becomes a positive because we always put the absolute value because it's an atom or an ion. And so we can't have negative atoms or negative ions, so it is always positive for subscripts. Okay, and now I'm just going to rewrite this without the charges so it's a little bit cleaner and doesn't have the arrows. Mg3, PO4, 2. Notice the parentheses have to be there or else it would look like 42. And you don't get rid of the 4 because it's in the parentheses. Everything in the parentheses stays the same. Okay, so what else can we do? Let's start off with a polyatomic. We have a positive polyatomic of NH4+. That's ammonium. And again, that's right off the poly sheet. Okay, and let's cross him with sulfate, SO4 -2. Again, right off the poly sheet. And his name is sulfate. And same thing still applies, even though I have 2 of them, I have to keep parentheses around it. So the NH and 4 get a parentheses and the charge goes outside. The SO4 get parentheses and the charge goes outside because that's what we're crisscrossing. So that 1 goes outside. The -2 becomes a 2 and it goes outside. So now I rewrite NH4 parentheses 2, SO4 parentheses, and really I don't have to write the 1 because remember the 1 is inferred, just like we don't write 1x in algebra, we write it just as 1x, or just write it as x, sorry. Same thing here, we don't have to write that 1, so we could even rewrite one more time. And write it as NH4 2 SO4. So sometimes you won't see those parentheses there, but it still means that there was 1 ion set of NH4, or sorry, 2 ion sets of NH4 and 1 ion set of SO4. And so that's what you need to be able to decode there. So even though we don't see those parentheses around sulfate, they are still there because everything, the SCO and the 4 combined together for a -2 charge.